In case of UDP, whenever the packet lost, that's all. You cannot get the packet again. And there is a possibility of getting the duplicate packets also in case of UDP. So mainly this TCP is designed to deal with these four things. So the properties of TCP will be like this. It is stream oriented. Where in case of UDP we'll call it as datagram. Here it is in case of TCP we'll call it as stream. Stream in the sense the flow of something. Especially we'll say water stream means flow of water. Like this here, flow of bits, flow of data will be there. TCP thinks of the data as a stream of bits divided into 8 octets. So that means 8-bit octets. So every data item will be treated as the 8-bit octets, and the whatever the main content will be there, that will be transferred or that will be communicated in the form of series of 8-bit octets. The stream delivery services on the destination mission passes through the receiver exactly the same sequence of octets that the sender passes to on the source machine. So if the sender has sent 1, 2, 3, 4 as a sequence of octets released from the sender, then in the same sequence at the receiving end, the service will receive the octets. And TCP will also support the virtual circuit connection, and buffer transfer will also be supported by the TCP. When transferring the data, each application uses whatever the size of pieces it finds convenient, which can be as small as a single octet. The protocol software is free to divide the stream into packets, independent of the pieces the application program transfer. To make transfer more efficient and to minimize the network traffic, implementations usually collect enough data from the stream to fill a reasonably large datagram before transmitting it. This is also called as push mechanism. So push mechanism can force a transfer without buffering. So here actually, this buffering will help us in dealing with the packet loss and packet delay. So whenever congestion is there at the routers or maybe in the network, because of this buffer, that is out of order delivery can be avoided by maintaining the small buffers in middle, so that if any missing packets have come, then that can be accumulated at that buffer and can be sent in a proper order. And one more thing is the stream that is passing is unstructured. TCP does not honor structured data streams. That is the responsibility of the application programs must understand the stream content and agree on the stream format before they initiate a connection. Basically, this TCP will support the full duplex communication. That means at a time both the sender and receiver can communicate. That is the reason we'll be having in internet both the uplink and downlink. As when you are downloading, you can also upload content. Okay, this is mainly required in case of websites and all. So this full duplex communication will be supported by the TCP. And it is more reliable because for every packet the sender transmits, he will get the acknowledgement. So positive acknowledgement with the retransmission will be received in case of TCP. Basically, UDP and TCP will be focusing on the topic of what call the ports, because whatever the data received at the IP layer will be received based upon the host address. But to which service that data has to be sent will be decided upon the port. So as like UDP ports, yesterday we have seen, especially in the case of the domain name service, which is binded to the 53, like that the application layer services will be binded to TCP ports. There exist various TCP ports supported, like 8080 for the HTTP, 443 for the HTTPS, like that. Many services at the application layer will be binded to the TCP ports. TCP ports, connections, and endpoints. So endpoint of communication is the application program, obviously. TCP uses the port numbers to identify the application. TCP connection between two endpoints is identified by the four items. What is that? Sender IP address, sender's protocol port number, receiver's IP address, and receiver's protocol port number. So this is the way it will be identified. So that is the reason if you want to communicate with any HTTP server, what to do if it is a local HTTP server, then you will use 127.0.0.1:8080. But if you want to access a HTTP server on local area network, you use the IP address of the system where the HTTP service is running on and :8080. Thereby you will get the service. And here reserved port, TCP port numbers will be there. Port numbers, as I discussed previously, port numbers will range from 0 to 65,536, and the port numbers from 0 to 1024 are reserved for the privileged services, and rest of the things can be used by the users. So here, example is like this: SSH, that is the Secure Socket Host, will be based upon the port 22. Telnet will be binded to the 23, and HTTP services will be binded to the port 8080 or 80. So whereas SSH, that is Secure Socket Host, Telnet, and HTTP will use the TCP as the service at the transport layer. Now we need to understand the TCP format, that is packet format. We can also say that it is a TCP segment format. Okay, it is also again 32-bit here. Here the first 16-bit is the source port and destination port, sequence number, acknowledgement number, header length, and not used. Here code bits, window, checksum, user urgent pointer, options, it may be omitted, padding, and beginning of payload. So the first up to beginning of payload, all are set to be the headers. Okay, all these fields are set to be header. In this, mainly you need to understand that the possibility of having the attacks is based upon the code bits. Okay, based upon the code bits. Okay, and mainly the attacker will try to modify these code bits to launch the attacks. So we'll discuss each and every field that will be used in the TCP segment format. And what we'll do is we'll mainly focus on the code bits. With this code bits only, there's a possibility of many security attacks will happen. And when we discuss the traffic analysis, we'll see how these code bits will be identified in the traffic analysis. So for that, we must have the understanding of the code bits and what is the meaning of these code bits. What is the type of packet or signal that the TCP wants to communicate when a particular code bit is on or off. So header length is the length of the segment header measured in 32-bit multiples, and it need to be optional for varies in length. Okay. Next is checksum. Obviously, checksum is especially used for maintaining the health of the header and checking the health of the header. And code bits specifies the purpose and content of the segment. Bits of the code field in the TCP header is like this: URG, this means urgent flag; ACK means acknowledgement flag; PSH means this segment refresh the push action; RST, which is called resetting the connection; SYN, which is called synchronize the sequence number; FIN means finishing of the sending information. These are the important flags that are going to be used as a code bit. Assume that if URG flag to be communicated to the destination, then the sequence of the bits, the URG will be set to 1 followed by remaining all zeros, so that the receiver will come to know that this segment is indicating the urgent flag, and the destination will perform the urgent flag related action. In the same way, if the sender wants to communicate acknowledgement signal or acknowledgement to the destination, then the first URG will be 0, then acknowledgement ACK will be 1, then PSH, RST, SYN, and FIN are zeros. Then the destination will come to know that the TCP segment received is an acknowledgement packet. Like this, the code bits you are supposed to remember, and based upon this adjustment of these code bits only, separate attacks will be performed. Next one is acknowledgement number. It specifies the sequence number of the next octet that the receiver expects to receive. So always the sequence number is calculated as the sequence number, especially the acknowledgement number is calculated as the sequence number of the original packet received plus 1. Anytime the receiver will have to reconstruct the 0 or more octets continuously from the beginning of the stream, but may have additional pieces of the stream from datagram that arrived out of order. The receiver always acknowledges the longest continuous prefix of the stream that has been received correctly. So this will be detected only with the help of the acknowledgement number. Then whenever the acknowledgement number is matched with the sending packets sequence number plus 1, then the destination will come to know that, sender will come to know that the packet has been successfully reached at the destination. Then what will happen? Then no retransmission will take place. Otherwise, retransmission takes place, because TCP will always guarantee the perfect communication. So whenever you use TCP, all the packets with 100% accuracy, it has to be received at the destination. So whenever how the source or destination, which are working with the TCP protocol suite, will come to know that the packet has been correctly reached the destination. It is totally based upon the acknowledgement number that it received. So acknowledgement number will play a major role. Many of the attackers will focus on the dropping of the acknowledgement packets. So they will try to tamper or drop the acknowledgement packets by intercepting, or by maybe via the man in the middle attack kind of thing. So what will happen is the destination will be very busy in sending the packets itself, that is acknowledgement packets itself. So thereby it cannot do any other task. So like that, the attackers may perform the attack. Next one is out of bound data. Although TCP is a stream oriented protocol, it is sometimes important for the program at one end of the connection to send the data out of bound. So whenever the out of bound data was sent, then it is the responsibility of the TCP at the receiving end to make it in the proper order, without waiting for the program at the other end of the connection to consume octets already in the stream. So for example, Control C interrupts or abroad the signal. So whenever you start the communication, then you press Control C or something, then you may not transmit the rest of the code. So in such a cases, the out of bound data is somewhat possible. So URG code bit is used to specify such type of TCP data. So whenever the URG signal is on and the segment has been sent, that means that by mistake we have sent the out of bound data. So we don't want to we want to refresh the connection, and the connection will be resetted. So this is URG pointer. It specifies the position in the segment where urgent data ends. Thereby, the destination will come to know that okay, the data received at the is because of out of bound, and there is no further communication, because the user at the sender might have double clicked, or we can say pressed Control C, so that there is a communication interruption. Next one is timeout and retransmission. Every time TCP sends a segment, it starts a timer and waits for the acknowledgement. If the timer expires, TCP assumes that the segment was lost or corrupted and retransmits it. So this is called adaptive retransmission algorithm. TCP monitors the performance of each connection and reduces the reasonable values for timeouts. So how these particular reasonable values for the timeouts will be maintained? This is based upon the congestion control feature of the TCP protocol. What is congestion control? So the TCP will use a beautiful mechanism called a sliding window protocol. That means whatever the stream of bits, that is the stream of octets, is there, those octets will be classified as a window. Okay, so that window will indicate that as the moving of the window indicates that uh, the window size, actually the whatever the window size is there, the window size will be fixed based upon the congestion that is available at the router level. So congestion available on the traffic. So if there is too much congestion, then the window size will be reduced. If there is no congestion, then it will use the maximum window size. So what is the meaning of this shrinking and growing of the window size? Is nothing but to deliver the packets with a higher accuracy or with a more efficiency. That is what the basic idea of this congestion control. Here, whenever and one more thing is how you come to know that this congestion control is available at the receiving at the traffic. So that is with the help of the ICMP, that is at the network layer. So this ICMP, whenever the IP packet is sending, so IP packet consisting of this TCP payload also, because from the top layer, that is transport layer, this TCP string will come and will be encapsulated in the IP, and this IP is going to be used with the ICMP, and the ICMP will know that whether is there any traffic available or is there any congestion available, because ICMP echo replies will be having the corresponding numbers. That is we have seen in the previous lectures. That is each and every ICMP reply will be having a specific code number. So that based upon the code number, the TCP will come to know that okay, there exists some there may not be exist root, or there may not exist there may exist some source quench, or there may exist some other problem on the channel. So thereby TCP what it will do is it based upon the signals it received from the lower level protocols, that is ICMP and all. So TCP what it will do is it will try to adjust the window size. So this is what we call sliding. So what the sliding window will do is the based upon the congestion, the window will grow and shrink. Okay, so the octets that are before the window are the octets for which the acknowledgement has been received. Okay, and in the window itself there will be some parts. That means some segregation will be there, in which the octets that have sent but acknowledgement has not been received will be maintained. And next afterwards, there are octets that are about to send will be maintained. So in the window, actually, it will maintain the octets that have sent but acknowledgement has not been received, and also the octets that is about to send will also be maintained in the window. So this is the way window will be maintained. So whenever the TCP comes to know that there is no congestion before, then what will happen is the window size will be grown, and more number of octets will be flowed into the traffic. Where in case of UDP, this kind of mechanism is not there. So that is the reason whenever the datagram has been sent, if it is received only, that's all. You cannot do anything in that. So if it is received, it is received. Otherwise, it will be dropped. There is no mechanism of checking whether the related datagram has been reached the destination or not. So that is the reason whenever you use any internet services, like especially browsing to the web server, web browsers and all, even though your internet speed is very slow, still you will be in a position to load the page. You will be seeing that your mobile or your device will be in a position to load the page, and you will be in a position to access that username and password, whatever the thing, or login or whatever the thing, even though the internet is very slow. Where in case of multimedia communication, like if you want to watch a video or any other thing over the internet, if your internet is very slow, you will get so much buffering. Okay, that if the buffering is provided by the application that you are running. Otherwise, what will happen? You never get the video on. So that is what the main problem there, because the video transmission and this kind of image or multimedia transmissions will be done with the help of the UDP, where in case of website and web communications will be done with the help of TCP. So this is what the advantage of TCP, even though the network traffic is or the internet connectivity is very slow, but still it will be in a position to access the internet. The device is going to access the internet because of the advantage or because of the features of the TCP like this. That is congestion control, maintaining of regulating the out of bound data, and retransmissions, acknowledgement maintenance, and especially the sliding window protocol. I hope you got this. Why the TCP is more important, more reliable in transmitting the data. And next one is forcing data delivery. Consider using the TCP connection to pass characters from an interactive terminal to remote mission. The user expects instant response to each keystroke. If the sending TCP buffers the data, the response may be delayed, perhaps for hundreds of keystrokes. Like, for example, chatting application is there. So whenever you send, immediately that has to be received at the end. If it is upon buffering and sending it, then it is just like zigzag questioning answering will be zigzag answering will be done in case of chatting. So TCP provides an operation called push operation. So TCP provides a push operation that an application program can use to force delivery of octets currently in the stream without waiting for buffer to fill. In addition, a segment with the PSH bit set is sent to the receiver so that the data will be delivered to the application program on receiving end without waiting for buffer to be filled. So the importance of PSH flag is that one. So this segment requests a push. That means without buffering, it is asking you to receive the data. That is what the PSH flag to be set here. So this is these are the important fields, especially in the TCP segment. And one thing is you are supposed to remember these segments either from the ARP to the TCP UDP. All the packet formats you should have image in your memory. Then only you can effectively work towards it. Or effectively understand and write rules or policies in case of intrusion detection and prevention system. Now we'll move on to the main concept of the TCP, that is called TCP connection establishment with the help of three-way handshake. Many of the attacks will disturb this three-way handshake to gain the control, or to disturb the traffic, or to create the denial of service. So many of the attackers will mainly focus on the disturbing of the three-way handshake. So what is this three-way handshake? So we all know that the TCP communication require both the client and server should be ready. So how the server will know that client is ready, and how the client knows that server is ready. So for that, a handshake will be happened. That will be done in three ways. That means three messages will be flown between the server and client. Thereby, it is said to be three-way handshake. So the three-way handshake is dealing with the establishing of the communication. That is establishing communication-oriented using three-way handshake. So in which what will happen? The first handshake is like this: the host A, who is the client, wants to connect with the server, host B. So what the host A will do is, host A sends an initial sequence number in its first packet to host B, which is called as a synchronous packet. So how can you say that a TCP packet is a synchronous packet? So when this particular code bit SYN is set to 1 and remaining all other flags are 0, then TCP will understand that it is going to create or it is going to establish a synchronous signal, so that it is requesting for establishing of the connection with the server. So this is the synchronous signal. So that is the first step in the TCP communication. So whenever any client wants to communicate with the server, first the client will send the synchronous packet. In turn, the server, what it will do is it will create a temporary buffer. Okay, it will create a temporary buffer for the connection to be established. So temporary buffer in the sense here, it will open a half-open connection. You can say half-open connection for establishing the connection between the client and server. So in order to get full confirmation, the second step will be going on. The host B receives the synchronous packet, responds with the synchronous acknowledgement with an initial sequence number of the host B. So whatever the initial sequence number will be there, with the sequence number, the host B will send a response. So this particular synchronous acknowledgement sequence number will be the sequence number of the synchronous packet, plus 1, includes an acknowledgement number that is 1 more than the initial sequence number. Okay, that means if the synchronous signal has sent with the sequence number as 1000, then the acknowledgement will be 1001. Okay, so this is the way the acknowledgement will be sent. So whenever this acknowledgement received by the host, that is the initiator, say here host A, then how host A will know that this is an acknowledgement packet? That means in that packet, in the code segment, ACK will be set to 1, remaining all other flags will be set to 0. Then it will come to know that the receiver will come to know that, or any of the computer who receives that packet, especially in this case host A, whenever host A receives the packet and gone through the code bits in which ACK is 1, so it will be feeling that, okay, this is an acknowledgement packet received from the server, and also it will check for which packet that I have sent this acknowledgement packet has been received. How host A will come to know? By observing the sequence number. Always the sequence number will be the plus 1 of the sequence number that is originally sent by the host A. So based upon this, the sequence number, then it will understand that okay, I have received the acknowledgement for so and so packet. Next, in turn of this synchronous acknowledgement, host A sends an acknowledgement packet to host B. Whenever this acknowledgement packet of the synchronous acknowledgement has sent to host B, then for the first synchronous packet, what happened here? Half-open connection is maintained by the server. Now, whenever this acknowledgement has been received, final acknowledgement has been received after sending the synchronous acknowledgement, then the host B will create a full-length connection. Okay, it will create a full-length connection and increases the host B's sequence number by 1, and it will establish the connection, so that whenever it is established the connection, then host A can send the original data. Now the main data will be sent. So this three-way handshake is to establish the connection. So the entire game of attack on TCP will be mainly depending upon this particular three-way handshake. That is, for example, if you look at this is the summary of three-way handshake. For example, connection request synchronous will be sent. In turn, then host B, what it will do is it will create a half-open connection. Then, in response to the synchronous, host B will say that I have received your synchronous signal, and this is my acknowledgement. Then, host A, what it will do is, in response to this synchronous acknowledgement, host A will send an acknowledgement back to the host B. Then, three-way handshake complete and connection is established. Once the connection is established, then host A will send the data, main data, to the host B. The first data frame has the same sequence number and the acknowledgement as the third packet of the three-way handshake. So this is what the thing. Now, during this communication, we have seen only synchronous and ACK the flags on. What is the case if different flags were set? URG flag was set, what is the PSH, what is the case if PSH flag was set, what is the case if RST flag was set, and what is the problem if a hacker guesses the initial sequence number? What is the problem if the hacker guesses the what could be the next sequence number? Then all these things are very, very important for us to understand the possibility of attacks. That means entire this three-way handshake disturbance is the main objective of any hacker to perform. So that is the reason one must have complete knowledge of this three-way handshake and this 4 bits. That is the reason I am stressing from long time that these are the very, very important concepts that need to be understood. So by this time you come to know how the connection will be established between the two parties in the TCP communication. That is with the help of the three-way handshake. So in which the host A will send the synchronous packet. Then in response to that, the receiver host B will create a half-open connection and sends the synchronous acknowledgement back. So the synchronous acknowledgement packet consisting of the sequence number, which is incremented by 1, that is the incremented by 1 of the sequence number of the host A initial synchronous packet. Then in response to the synchronous acknowledgement, host A will send back the acknowledgement back to host B. So this is the way the connection will be established. Now you look at the synchronous packet, for example. From host A, the TCP source port is 26,077 and destination TCP port is 80. The sequence number is 50088. Currently, there is no acknowledgement flag set. Initially, it is 0 and flag is synchronous signal. Now, sending computer is host B and the source TCP port. This is for the synchronous acknowledgement. The destination TCP port is the port that from where this synchronous packet is originated. That is the same port you are supposed to mention here. Next, the sequence number. The sequence number may be different for this host B because the host A is different and host B different. So host B sequence number may be this one. Acknowledgement number, if you look at it, acknowledgement number is equal to 5089. Why it is 5089? This is the incrementing plus 1 of the 5088. Okay, plus 1 of the 5088. And flags are synchronous and ACK flag was set. And here only synchronous flag was set. So now assume that an attacker is sitting on the communication channel and spoofing the packets going on. And he identified a synchronous acknowledgement packet which consisting of the sequence number acknowledgement number as 5089. Now, whenever he observes the acknowledgement number as the 5089, then what you can understand? That means the recently gone packet or recently transmitted packet from the source to destination is 5088, which is a synchronous signal. Okay, because this is a synchronous acknowledgement because they can understand what is the bit was set. So synchronous bit was set and the ACK bit was set. When both the bits were set and the acknowledgement number was found as 50089, then they can easily guess what is the previous sequence number, utilizer sequence number by the host A. Then he may fabricate a packet. Because this packet consisting of the sender address and the receiver address, as we have seen previously, for any TCP communication, what you require, you need to have a sender address, sender's port number, receiver address, and receiver port number. So that is the reason the attacker can fabricate a packet with the host A's address and host B's address and port number as 2077, and sequence number may be the higher than the sequence number because once the sequence number is already utilized, the same sequence number cannot be used again in the communication. They have to go for creating of or using of a new sequence number. Okay, so that is the reason attacker what he will do is he may fabricate a packet with a higher sequence number than the sequence number he observed. So obviously the server will believe that okay, this is the original packet has received from the host A. So then server will respond to that packet. So like that, the attacker will try to include some fabricated packets into the system. This is the way we can do one thing. And second one is we want to make the server to not to respond. So for that, we have seen just now that whenever the synchronous signal was sent by the host A, then host B, what it will do, host B is doing what, it is opening a half open connection. That means some buffer is created for full establishment. But here, since only first synchronous signal is received, it is not going for complete establishment of the connection. It is only opening half open connection. So this half open connection is said to be buffer or some temporary memory will be created, and this will be lost for at least 75 seconds. So in such a cases, if I have sent a flood of synchronous signals to the host B, then for every synchronous signal, then host B has to, what it has to do, it has to create that many connections, or that much memory has to be created. So now what I am doing is, the attacker, what the attacker can do is, he can create some fake identities, IP addresses, and he may send a synchronous signal from each IP address. Thereby, what will happen? That much memory will be created. Then, even the host B respond with the acknowledgement signal for the synchronous signal that he receives, but the attacker will not respond to that. Okay. Thereby, what will happen? The whatever the half open connection is there, the host B has to be maintained at least for 75 seconds. Like that, if you perform incrementally, then more memory has to be maintained at the host B, and thereby it will be leading into the denial of service attack. Like that, the total TCP attacks, is totally depending upon this three-way handshake and its management, and especially the signals management, that what happened in the what will be performed in the three-way handshake. Now we will move on to, after understanding this three-way handshake, I hope so, you might have understand by this time. We'll move on to the TCP attacks that are performed on the TCP three-way handshake and other things. The first one is SYN flooding, that is synchronous flooding. Just now I told you, an attacker sends many synchronous packets to create multiple connections without ever sending an acknowledgement to the complete connection. So whenever the synchronous the synchronous was sent, but in response to that, host B is a very genuine one. He believes that, okay, the one who is sending the request is the genuine request, and it will send the acknowledgement signal. But in turn to this acknowledgement signal, the host A has to send the acknowledgement back. Then only the connection will be established. Till that time, it will only maintain in buffer that somebody has sent the synchronous signal, somebody has sent the synchronous signal. Unless until it receives the acknowledgement, then it cannot give you the correct establishment of the connection. So whenever this attacker will receive the acknowledgement signal, synchronous acknowledgement signal, then he never sends the acknowledgement back. Thereby, what will happen? More memory has to be spent at the host B. Then when more memory is spent, then automatically it cannot devote a memory for the original processes or genuine processes. Thereby, it is looking like a denial of service attack. So the victim to keep off the half open connection in its memory for certain amount of time, that is around 75 seconds. If there are so many of these malicious packets, the victim quickly runs out of the memory. Thereby, it is going to create the denial of service attack. Those synchronous packets usually use spoofed address. That means some fake addresses, or the addresses that are spoofed in the network will be used for this purpose. So I hope by this time you come to know the synchronous flooding attack. Next is the TCP session hijacking attack. So in what possible ways a session of the TCP can be hijacked? Only thing is when you can know the sequence number, it is possible to attack the session. So the discussion is like this. This TCP session hijacking is also said to be Mitnick attack. So Mitnick is the first kind of hacker, we can say, who is the first one who tried this TCP session hijacking attack when this TCP IP protocol stack has been introduced in the operating system. He was sentenced for at least around 5 years jail in USA. Afterwards he became very famous hacker, and he knows all the loopholes of the TCP IP protocol, and he became a very prominent person afterwards. Now you can also type Mitnick in Google, and you will get his profile and his details. You know, he himself is running a security company in USA. Okay, so actually, this is the innocence of the TCP, but this innocence of the TCP is exploited in various ways. So that is the reason some security layers will be attached whenever the web communication is going on, such as transport layer security (TLS), secure socket layer, and this kind of things has been introduced afterwards. But in the beginning stages, when the first Web 1.0 is there, this kind of security is not there. So that at the time, this Mitnick attack was famous, and later on, many people, many attackers have tried this Mitnick attack and got success. So TCP session hijacking, which is also to be Mitnick attack. You may go through the Mitnick attack on the internet, and you can get some more information on this. The discussion is like this: Mission A and Mission B. If a user R login from B to A, that means remote logging from the B to A will not ask for the password because it is a remote source. Okay, you are an attacker. Can you log into A from your own mission? This is the question. That means it is just like a man in the middle. Okay, so B is trying to log in into A. You are as a hacker or an attacker. You are sitting on the communication channel. Can you in a position to log in from your own mission? This is also called as session hijacking. Okay, so this can be done via ARP cache poisoning, or maybe via fragmentation, or maybe via in many ways, depending upon the protocol that you target. But here, especially in the case of TCP, it is said to be session hijacking of the TCP. How it is possible? First one is, hint one is sequence number is the one thing that you can do it, and hint two is B's role. Okay, B role is there. That means if the B's information is known to you, or some information is known to you, then you may make use of that. Otherwise, the first option can be utilized. That is the sequence number, guessing the sequence number of the session. Okay, and flood the B with a huge number of synchronous signals. Okay, so these are the two things you can do, so that synchronous B is very busy in answering to the synchronous signals. In meanwhile, when you guess the sequence number and the sequence number is the correct sequence number, you can establish the connection with the A. Thereby, B cannot connect with the A there afterwards, because already you have connected to that. So this is the main thing. And for that purpose, in order to guess the sequence number, in general, TCP packet or TCP communication, it will be initiated with the random sequence number. You cannot guess what could be the sequence number. So that is the reason randomly one sequence number will be started. From there onwards, the incrementing procedure will happen. So never the sequence number will be 0 in the TCP communication. That means TCP communication sequence numbers will never start with 0. Always it will start with the random numbers. There afterwards, it was included, and some more security features were added that we'll discuss afterwards. TCP RST attack, that is sending the reset pin. So what will happen whenever the reset pin was set in any of our components, electronic components or somewhere, that will be rebooted from beginning. Okay, that will be rebooted. So like that, RST is a signal which is especially to indicate that resetting of the connection. Attacker injects an RST segment into an existing TCP connection, causing it to be closed. The TCP reset attack is made possible due to the requirements that the TCP endpoint must accept out of order packets that are within the range of the window size, and the fact that reset flags should be processed immediately. Whenever you send the push signal, PSH signal, then it will accept out of order. That means as it is, as the packets coming, the receiver has to send. Receiver has to accept that. But when this RST is set without having any expressing any doubt or expressing any expressing any information, the endpoint must close the process immediately. That is what the intention of the RST. So this particular RST will be exploited by the attackers just by guessing the sequence numbers. That means first they will go through the acknowledgements, and with the acknowledgements they can guess what could be the next sequence number coming, and in how fast this communication is taking place. Based upon that, they can estimate this particular sequence number can come in the next how much time. They may fabricate a packet, and they will send the RST signal to the destination, to the server, so that thereby the connection will be reset. So what are the difficulties of spoofing the RST packet to break a remote connection? First one is, as I told you just now, sequence number of connections. Next one is source port of the connection. So what is the source port? To which port you are going to send this reset signal? So this will be identified. So source port of the signal, destination port is usually well known for some applications. Like secure socket host is 22, FTP is 23, or HTTP is 80, like that. But if it is a user-defined application, you don't know what is the internal port it is used. But the standard applications like SSH or FTP or the HTTP or HTTPS, the standard ports are used generally. So these are the two difficulties. First, guess the sequence number and know the port number, then your work will be done. Now, TCP port scan attacks. Let us see the TCP port scan attacks, in how many ways this port scan will be conducted. So we all know that the TCP and UDP will mainly focus on the ports and ports related services. That means sending the data to the related services which are binded and running on the port. So use of port numbers is not unique. However, some part of the numbers become standard for certain services. So we cannot use those services, other services for that ports. Port numbers are 16-bit unsigned numbers. So the reason 2 power 16 ports will be available in any computer. In general, port numbers are divided into two ranges. As we know that standard ports 0 to 1023, like FTP, FTP data, FTP acknowledgement, or this communication with the TCP is 21, FTP data with UDP is 20, and SSH is 22, telnet 23, time is 37, time 37, timestamp is 37 on UDP, who is 43, and IMAP is 143. Like that, standard port numbers are there. So all these port numbers, I hope you know it. There is no much discussion required on this. So port scanning techniques. So how you can say that this port scanning will be done? So this TCP connect scanning is one kind of port scanning technique to know what are the services running and how alert that system is, and what is the operating system running on, whether the firewall is on or off. This kind of information you can get via this TCP connect scanning. Next is TCP synchronous scanning, often referred to the half-open scanning. Not open a full TCP connection, provided it sends a synchronous packet as if a real connection is open. Then await for the synchronous acknowledgement, and if a synchronous acknowledgement is not received, then the RST to tear down the connection immediately. Kernel will do it for you. That means the operating system kernel will send RST whenever the synchronous acknowledgement has not been received. So this is a synchronous scanning. And the finished scanning, that is FIN signal, sending of the FIN signal. Sometimes the synchronous scanning is not sufficient enough. So because the reason is many of the synchronous scanning related packets will be filtered by the firewalls. So some firewalls and packet filters which were synchronous to restrict the ports. So finished signal may be able to pass through in that, because whenever a finished signal has sent, firewall cannot deny that, because it is a top urgency that we have to close the connection. So that is the reason firewalls never stop such kind of finished signals. So closed ports tend to reply finished packet with the proper reset signal. So open ports tend to ignore the packets in question. So this is required TCP behavior. So however, some systems are broken in this regard. They send RST regardless of the port state. Thus, they are a vulnerable type of scan. So that means whenever the finished scanning was performed, if any port is responding, even though it is closed, that means that the operating system is having some vulnerability. So we can focus on those ports to exploit the vulnerabilities to gain the access of the system. This is the way attacker will do it. But in real world, how can you do this? In real world, you can do via some popular tools such as NMAP, network mapper. So you can use NMAP tool and you can perform this scanning techniques, and you can do it. I will post you a video in which you can learn that how this NMAP can be used for scanning the systems. Anyhow, in the ethical hacking course, I have provided some videos on how to perform the scanning and all. You may go through that, or I will give you the link here, and you can go through that video. Next is TCP reverse indent scanning. TCP reverse indent scanning. The indent protocol RFC, request for comment 1413, allows for the disclosure of the username of the owner of any process connected via TCP provided by port 113, even if the process did not initiate the connection. You can, for example, connect to the HTTP port and then use the indent to find out whether the server is running as root or not. This can only be done with the full TCP connection to the target port. So this indent scanning can reveal the user information, and for this also, along with NMAP, you are supposed to use several options to perform the this kind of scannings. Like a hyphen, for example, NMAP space hyphen small s capital S or small s capital F. Okay, so scan with the finish signal. Okay, this is what the option that you are supposed to use. Like that, you need to use the scanning. Next one is finish scan, XMOS scan, and null scan. So finish scan, FIN scan. The FIN scans frame are unusual because they are sent to device without first going through the normal TCP handshake. If a TCP session is not active, the session certainly cannot formally closed. So usually, the server will see that whether this finish signal has been sent by already connected device or not, because connection, what are the connections are there? Because server can remember who connected with it. So you can go through that whether this finish signal has received from so and so connection or so and so the connected device or not. But if whenever attacker has sent any finish signal with different IP addresses than he guessed it, so obviously if that IP address is not available in the connected list, then the FIN signal will be received by the server, but it will be in a position to unable to decide whether who has sent this finish signal. So thereby what will happen? Whatever the port number available in the finish signal, the corresponding services will be closed by the system. So thereby before closing, the server, what it will do is it will send the reset signal to the source. So source also is in dilemma that why the server has sent the reset signal. So in this way, the dilemma will continue on, and there is in order to establish the communication again the TCP three-way handshake has to perform again. The connection will be established, has to be established. The XMOS tree scan. The XMOS tree scan sends the TCP frame to remote device with the URG, PSH, and FIN flag set. This is called as XMOS tree scan because of the alternating bits turned on and sent. So that means like a Christmas tree, okay, how the Christmas tree lighting will be done, like zigzag lighting will be done. In the same way, in the code bits, so some alternative bits will be set to on and will be sent. But you can send a URG signal at once, either you can send a push signal at once, or you can send the finish signal at once. How can you send all the signals, that is the signals such as URG, push, and finish signals set to one? So this is what the XMOS tree scan. Basically, it will reveal some sensitive information whenever the XMOS tree was performed. Majorly, to detect this XMOS trees, we can write rules in the intrusion detection system or at the firewall level. So firewalls can easily detect if some strict policies have been adopted. The main thing is URG, PSH, and FIN are used for a specific purpose. You cannot turn on all these three specific purposes flags at once in a packet and can't be sent. So then it will create a dilemma, and thereby the systems will be in a confusing state. In such a cases, some services may reveal the sensitive information. That is what the basic idea of XMAP scan. And null scan is nothing but all the flags are turned off. There is no reason why if you turn all the flags, what is the need of that particular signal or that particular packet? So every packet has to convey some meaning, either URG or either push or either finish. But if all the signals are zero, then still, if since all the signals are zero, then the receiver will confuse and will send a reset signal. So ultimately, this finish XMOS and null scan aim is to get disconnected from the server. This is what the ultimate aim. Okay, these are the major scanning techniques. Major scanning techniques will be performed to get either by sensitive information or to get the disconnection from the server. Next one is OS fingerprinting. OS fingerprinting means what is the operating system used on the target, and what is the operating system version, and what type of operating system it is, either Windows or Linux or what it may be. So this is the guessing the remote operating system. It will be done with the OS fingerprinting. So the link I have provided here in the chat box and this one. So you may use that link and can come to know the OS fingerprinting also to know what is the operating system on the target machine. For example, NMAP -S capital T -P 80 -L -O, and this is the website name. So whenever I mention this NMAP like this, so this is the TCP scan -ST, and on the port 80, it is going to get the information -L capital O means it is going to give you the information of the operating system. So remote operating system is Solaris 2.6 or 2.7 version, and uptime is 33.199 days. So from 33.199 days, this solar system is on and giving you the information about the operating system. That means the solar system kernel may be of 2.6 or 2.1, 2.7. Maybe it may be in this range. So what the attacker will do is attacker will identify is there any vulnerabilities present with these versions or not. So whenever is there any vulnerabilities present with these versions, then they will try to use those vulnerabilities and try to exploit on the target computer. Then the target computer may be exploited and the system may be hacked. So this is the way the attackers will perform the scanning. And this is one more scanning technique where you will get the information about the users and services that are running on the so and so target. So you may also try at your end by following the video or by using this NMAP tool. So one thing is NMAP will always generate huge traffic. Okay, it generates huge traffic. Normally, if the traffic is of around KBs or something, whenever you use NMAP, the traffic it will be in terms of MBs and GBs. So thereby using the intrusion detection systems, you can easily identify that somebody is using NMAP to scan our computer. Okay, if our computer is having an intrusion detection system and with all the proper rules were set, then immediately it can easily identify that so much traffic is coming, abnormal traffic is coming into the computer because of some NMAP scan. Okay, so that is the reason it is always dangerous to use NMAP scanning, and it is better to use some other techniques, some other scanning techniques which are somewhat costly and proprietary also, which will generate low traffic and will get information. But NMAP is the tool which is open source and freely available. So at the student level, for learning purpose, you can use this NMAP tool without any doubt. But one thing you remember, NMAP will always generate a huge traffic with which you can be identified sometimes. So In the beginning stages, I have shown you the computer emergency response team. They have projected that these many scannings were, these many attacks were performed, especially the scanning attacks are like this. Okay, how they will know? That means they have proper intrusion detection systems with that means the corresponding organizations may be having the proper ideas with this kind of rules were set. So automatically they will be recording that who is using and what type of scannings are performing on the things based upon, especially based upon the abnormality of the traffic that is coming into the organizations. They will easily identify the attacks and they will report in their annual reports. So fragmentation scanning. So in general, if you scan normally, huge traffic will be generated. So to escape from the firewalls or IDS, it is better to scan in a fragmented way. So we have seen the fragmentation. What is the advantage of fragmentation? Instead of sending the big packets, it will divide into small number of packets, maximum of 400 bytes, and will be sent. Whenever small packets were sent, firewalls cannot filter them, and they will go into the system, and they will try to get the information related information whatever the system whatever the attacker requires. So these are said to be the fragmentation scanning, and basically this fragmentation scanning cannot be detected via firewalls, and this will also be used by the attacker to know the firewall state information, whether the firewall is on or off. Its kind of information can also be identified with the fragmentation scanning. Next is FTP bound scan. Take advantage of vulnerabilities of FTP protocol. Require support for proxy FTP connections. So then if you come to know whether the file transfer protocol in servers are having any vulnerability or not, then they will come to know they will try to exploit those vulnerabilities by applying certain payloads, and they will break into the file FTP server and may steal the files. And UDP ICMP ports unreachable scanning also there. So whenever the unreachable scanning is there, then they will reveal some information. Like protocol is simpler, but scanning is more difficult. Open ports don't have to send an acknowledgement. Closed ports are not even required to send an acknowledgement, error packets. So most hosts do sending an ICMP port unreachable error when you send a packet to the closed UDP ports. Thereby, you will come to know that whether the port is opened or closed. Cannot find out if a port is not open in the case of this searching or scanning. Neither UDP packets nor ICMP errors are guaranteed to arrive. And the disadvantage of this attack is it's somewhat slower. The ICMP error message is rate limited. Need to route for access to raw ICMP packets. And here UDP received from and write scanning. Non-root users cannot read port unreachable errors directly. So that is the reason whenever you are using NMAP tool, you are supposed to use in the super user mode or administrator mode. Next one is stealth scan. Some simple port scanning can be used by logging the services listening at the ports. They see an incoming connection with no data, thus they log an error. So stealth scan refer to some scanning technique to avoid being logged. So we all know that the operating systems will log every activity that is happening in the system, but the stealth scan will allow you to escape from logging by the operating systems. And we'll get the information about what are the open ports, closed ports, operating system information, everything. Other stealth scans are like scan slowly, firing packets with fake IP addresses. So thereby, even though some operating systems were logged the thing, you will get the fake, only fake IP addresses will be recorded at the target level. Next one is the detection of port scanning. So idea of non-stealth scan detectors. So here you can write the programs for this to know whether the port scanning is going to be performed or not. Afterwards, when we are discussing this traffic analysis, we'll see what are the packet captures so that we can with the packet captures what are the fields that with which we can identify the port scanning is happening on the target. So like this, we can write our own programs, like especially in case of Unix operating system, you may get the book called Unix Network Programming. That is a book which is very famous for writing your own programs to perform the communication, especially like socket communication and initiating the TCP communication, in which you will be having the default packages like this, libraries like this, which are built in C programming. Here received from this IP port to underscore IP socket sock underscore raw. These are the predefined values that are used in the C program libraries, that you can directly use them in your program and can perform the programming for writing your own programs for scanning. So as I told you in the beginning, that the experienced attackers will not use the open source tools. They always write their own scripts for performing the tasks. So that is the reason in writing the task, in writing the programs, C programming is the one which is the topmost and best programming language that you can use for the hacking purpose. So they use this TCP libraries especially for writing their own programs and to get the work done. So this is what the thing related to the TCP attacks. Especially the TCP attacks will focus on the disturbing of the three-way handshake. How this three-way handshake means? That is disturbing of this using of these 4 bits and utilizing these 4 bits for performing the disturbing of the TCP three-way handshake. So entire TCP attacks focus on, again, once again to conclude, again I'm telling you, the entire TCP attacks will focus on the disturbing of these attacks or misusing of these signals. So thereby the entire communication will be get disturbed.